Okay, last one from this packet. Just trying to get something set up. They don't, again, with none of these we've had anything other, specific like bisects or midpoint or vertical angles. We've had to go pretty much just off of, well, either segment addition postulate or angle addition postulate. The two smaller add up to larger, and that's as specific as we can be. But we've been using replacement rule a lot with these. So before we get any further, I'm going to go ahead and change the measures here to being equal, just so that I can easily be ready to replace them when I need to. The conditions of replacement will say that two measures have to be equal in order to replace them. So the statements they gave me don't meet the conditions to use replacement rule. So not a biggie, just going to change them to equals. Definition of congruency means if something's congruent, all the measures are the same, and with segments, there is only one measure, so that one measure, the length, is equal. That's what it means to be congruent. So I'm just going to say definition of congruent segments. And then let's try to get a couple equations set up here from our picture so that we can replace. In general, give me two small that add up to larger. It's going to be segment addition postulate. If you want to pause the video and see what you get on your own, that's fine. Otherwise, I'm going to keep going. I'm going to say the measure of AC plus the measure of CE equals AE, and then also the measure of BD plus the measure of DE equals the measure of BE. And if you look, I don't have anything doubled up there. I don't have anything I can replace in that equation in and of itself unless I use the couple things that we were given. Well, do you see that the sums are the same? Actually, we could replace the AE with BE and have them the same total. But what I'm actually going to do is I'm going to take this equation, a little bit different. But again, a lot of different ways to do this. So if you did it differently, doesn't mean it's wrong. Maybe you replace something else first. So I'm going to take this equation. What can we replace AE with? What else equals AE besides in this one that I have circled? Well, the measure of AC plus the measure of CE does. So I place AE with those two sums. Or what else equals BE? Well, I can replace BE with, it says that BE is the same as the measure of BD plus the measure of DE. A lot of students take a couple steps to do that, which is fine. They replace the total first, then they'll set the two sums equal to each other. But by replacing it in that first equation, you can actually do it in that first step, or that very next step here in 4. Okay, so if we're trying to show that AC and BD are the same, that means CE and DE should cancel out. And look at that. That's the other thing they gave us. If they didn't give us that, then what we're trying to prove would not be true. So I'm going to be able to cancel those out. I just have to make sure that I show that they're the same thing. So just one more time, I'm going to replace. Everything equal all the way to the end. I get to DE. What can I replace the measure of DE with? I go all the way back up there. CE equals DE. The measure of CE is going to replace the measure of DE. Replacement rule a couple times there. And then if I get to that point, looks like I can subtract the CE. You don't necessarily have to show that, but I'll just squeeze it in there just so you can see what's happening. That's really canceling it out, but we're not using a cancellation property. We're subtracting something from both sides of an equation. So what property says that you can add or subtract something from both sides of an equation? That's APE, additive property of equality, says that. Do I have to switch the order? Nope. So I got lucky there. No symmetric property needed. All I need to do is change back to congruent. So to prove something congruent, you need to show all the measures are the same. And there's only one measure for a segment. It's the length. So by showing those measures equal, that's enough to prove that they would end up being congruent by what it means to be congruent. So we'll just say definition of congruency. Therefore, segment AC is congruent to segment BD, a formal 2-column proof of that.